Hi peeps, today I will show you how to take notes so that you can quickly refer back to them when answering TOEFL listening questions. To do that, you need to know how to make paragraphs. If you don't make paragraphs, you'll end up looking for information all over the place and might not even find it, even though you did scramble together it. I will also show you how to use transitional words to make paragraphs. This astronomy lecture is very interesting. Theories relating to asteroids and comets can be difficult, but they have been on TOEFL reading and listening often enough that you need to have some background knowledge. This will help you orient yourself when reading or listening to the passages relating to astronomy. In this lecture, we'll learn a new theory of how the asteroid belt would have formed. The old theory for the formation of the asteroid belt is the planet explosion theory. I learned about this theory from a TOEFL listening lecture on Bode's law, which was one of the most aesthetic lectures on TOEFL listening, at least to me. Let's take a listen to the lecture.
Okay, today I want to discuss asteroids, how they are formed, where they are located in our solar system, and why. This picks up from where we left off last time, discussing the characteristics of comets. Now, as we talked about, comets are mostly composed of ice, and asteroids, on the other hand, are mostly composed of rock and metals. Comets and asteroids are kind of the leftover junk that resulted from the solar system's formation, about 4.5 billion years ago. Comets and asteroids usually form in different parts of the solar system for different reasons. Now, interestingly, we didn't know for sure how asteroids were formed until about 60 years ago. Scientists used to think that there was an ancient planet in our solar system that exploded for unknown reasons. And when it did, its remnants remained in orbit around the sun and formed what we know today as the main asteroid belt. This belt is located between Jupiter and Mars. Most asteroids in our solar system are found in this belt, and this fact seemed to confirm that the planetary explosion theory had some merit. But actually, if taken all together, the asteroids in this belt would still not even come close to the size of the Earth, hardly enough to have formed a full planet at one time. Also, some asteroids exist elsewhere in the solar system, and scientists were unable to explain how they got there using the planetary explosion theory, so they had to look for a different explanation. And they found one. It's called the nebular hypothesis. According to this hypothesis, our solar system began as a collection of gases and dust. These materials had mass and therefore exerted a gravitational pull, like all materials do. So each small piece of mass was attracted to the others. So they all started slowly moving toward one another, mostly in the center. As more mass entered the center, its gravitational pull became stronger and stronger. Eventually, enough mass collected there that the sun was born. However, not all matter made it to the center. The rest of it collected in a circular disk, more attracted by gravity to other pieces of matter in the disk itself than to the sun, because these other pieces of matter were so much closer. From this disk, all of the planets, moons, and other objects in the solar system were formed, including asteroids and comets. The planets and moons represent the larger collections of matter, and the asteroids and comets are the smaller collections of matter. Now, why did some of these pieces of matter form larger collections and eventually become planets, while others remained separate asteroids? The answer mostly has to do with two factors: proximity to the sun and the gravitational pull from larger bodies, the planets, in the solar system. First, proximity to the sun. Any collection of material that is close enough to the sun cannot remain an independent object for terribly long. Either it will collide with and become absorbed by one of the innermost planets, Mercury, Venus, the Earth, or Mars, or it will be sucked into the gravitational pull of the sun. But does anyone remember what is the next planet in the solar system after Mars?
Isn't it Jupiter?
Yep, it's Jupiter. And what do we know about Jupiter?
Oh, it's the biggest planet.
Thank you. That is correct. So, because Jupiter is so much bigger than other planets, it exerts a much stronger gravitational pull than anything in the solar system besides the sun. Any material that is located between Jupiter and Mars is going to experience a strong gravitational pull from both Jupiter and from the sun and inner planets. The pull from Jupiter is so strong, in fact, that it makes it really hard for these smaller collections of material to combine with one another. They're just traveling too fast. So they collide and bounce off of one another, rather than sticking to one another. Also, many of these objects have been pulled into Jupiter and become part of that planet. What remains is a bunch of objects that can't combine with one another, haven't yet been sucked into another planet or the sun, and haven't escaped the opposing gravitational forces of Jupiter, the sun, and the inner planets. Hence, the main asteroid belt. Now, it's possible for asteroids to escape from this belt, and they do from time to time. These strays can be found throughout most of the solar system, but they tend to be small. Practically all of our solar system's large asteroids are either found within the main asteroid belt or are considered Trojan asteroids, meaning asteroids that form a cluster and follow Jupiter in its orbit.
Okay, now let's answer the questions.
1. What is the main topic of this lecture?
Question 1. This is a main topic question. The answer is in the first paragraph when the professor says, "Today we will..." Let's evaluate each choice. A. He did mention this in the first paragraph, but it's not the main topic for the lecture. He said that today he will talk about how asteroids were formed and why they are in the location of the asteroid belt. B is what we are looking for. C is the main topic of the fourth paragraph. D. Two theories are actually mentioned: the planet explosion theory and nebular hypothesis. But they are not competing theories. The professor believes that the nebular hypothesis is far better than the old explosion theory. So the answer is B.
2. What explanation does the professor give for why all planets and asteroids have not yet been pulled into the sun?
Question 2. The answer is in the third paragraph. That they are pulled by nearby matter. So A is what we're looking for. B is BS. C is not it, nor is D. So the answer is A.
3. What does the professor say about Trojan asteroids?
Question 3. Trojan asteroids were mentioned in the fifth paragraph. They are large in a cluster form and they follow Jupiter's orbit. A, B, and C are all false. D is right. They are located in Jupiter's orbit.
4. According to the professor, what feature of an asteroid generally determines whether it is likely to be absorbed by another planet or the sun?
Question 4. The answer is in the fourth paragraph. If some matter is close to the sun, the matter is absorbed by the planets or by the sun. So B is the answer.
5. What are 2 points the professor makes about why the planetary explosion theory is incorrect?
Question 5. The answer is in the second paragraph. The professor mentions 2 problems of the old theory. One is that the total quantity of the asteroids in the asteroid belt is not sufficient to make one planet. And the second problem is that some asteroids are found in areas other than the asteroid belt. B and C are the answers.
6. Why does the professor say this?
Any collection of material that is close enough to the sun cannot remain an independent object for terribly long. Either it will collide with and become absorbed by one of the innermost planets, Mercury, Venus, the Earth, or Mars, or it will be sucked into the gravitational pull of the sun. But does anyone remember what is the next planet in the solar system after Mars?
Isn't it Jupiter?
Yep, it's Jupiter. And what do we know about Jupiter?
Question 6. But is the clue. Before the but, the professor talks about the powerful gravitational force of the sun. Since he used a contrasting word but when he introduced Jupiter, we can infer that Jupiter also has a powerful gravitational pull. A is not it, B is not true, so it's C. D is what we're looking for. That is, Jupiter is almost as awesome as the sun. That's all I have for today. Don't forget to visit my website, www.naniburns.com, to learn more about all the courses and tutoring I offer. Have a nice day.